So hello viewers and welcome back to another video on Web-NS3. So in today's video we're going to explore that how we can generate this cool looking graphs, and these are not just cool looking graphs because these are the graph for TCP cubic algorithm. And if you see, we have lots of data, lots of stuff, lots of data, lots of runs executed for the same script, and we can see and we can observe all those different kind of graphs with just one click away. So remember, if you we had already a video on the comparison of TCP and cubic algorithm. So back in the days, what we were used to do is we used to run the NSS script, and then we store the data on some file, and then we used to GNU plot those data into some graphs, and then we save this graph somewhere else, and we used to do this stuff repeatedly several times. Or else how we can automate this stuff is by creating an shell script. So this is not we are required to do in now, because we have this Web-NS3. So in today's video we are going to see that how we can use Web-NS3 to generate the cool looking graphs with just a few clicks. If you considering the case that you have already the script, NSS script, and that is already available at inside the example scripts of the NS3. So we are going to leverage all those stuff, existing script and Web-NS3 in today's video. So without wasting much time, let's get started. So currently I am on my virtual machine, and before I start this video I should mention that I am very thankful to Mr. Jingzhu, because I had a talk with him and he is very helpful to me, because he had given me the full access of this Web-NS3 so that I can explore all the features and I can leverage all the features of Web-NS3 to make videos. So if you see, we were not seeing this option before, and we will also not see this option as of now, because if you have a free subscription in your account, then you won't be able to see this. And as we have the premium account, we have this option to choose the whatever build of NSC that we want. So that also we are going to explore in future videos, but I just thought to mention grateful thank to Mr. Jingzhu, and whoever watching this video. We are planning to make more videos on Web-NS3 featuring more ways to utilize NS3. So behold your horses till then. So without wasting much time, let's get the main thing of today's video, main agenda of today's video, getting started to discuss. So if you are new to NS3, then I should not recommend you to watch this video, because in this video we are not going to explore the how we can write the scripts, and I will not be explaining the technical, the coding stuff regarding the NS3. Rather, I'll be explaining that how we can use Web-NS3 so to automate and reduce some of your tasks. So considering that case, let's start the discussion. So first I would like to bring attention that we have this fifth.cc file, sorry, not fifth.cc file, 6.cc file. So if I'll just open the 6.cc file, again this file is not written by me. This is already available at examples tutorials. Under the tutorials folder you will find the 6.cc file, and if you see, we are using this tutorials app.h file that is also defined over here. And what this file is doing is basically, if you see over here, so we are creating the error model, and we are using this congestion window change option. So whenever, so trace source basically, so whenever we have this congestion window change event, so if you know a little bit about TCP, so there is a congestion window. So what are the number of packets that we are going to send? If you take it very this congestion window to the bottom, so this is nothing but the number of packets that we can send, that the TCP can send. So now this file is responsible to generate the trace sources, and trace sources is nothing but the at what particular second the congestion window has been changed to what value. So this is function that will log those stuff. And using this stuff, if you remember in our earlier video, so this was the video where we were using GNU plot to plot the graph, and we were concluding the how TCP beacon cubic behaves whenever, let's say, the bandwidth of channel is, let's say, 10 Mbps, and we are changing the application bandwidth to 1, 10, 5 and particulars, or any random value between 1 and the maximum bandwidth of the channel. So this we used to do, but now since we have NS3, we are not required to do all those stuff by manually. So we were required to do this stuff manually per simulation that we wanted to simulate and we wanted to check for. But now let's say I want to automate all those stuff, and that is very easy because now we have Web-NS3 and something called, so if we upload any of the scripts, so let's say if we go to dashboard, if we edit our file, so if you see all those parameters, number of runs and parameter sweep that we have over here, that is very useful, and in such a way that you might be thanking a lot to this feature once you start to understand and use this feature. So now we are using this 6.cc file, again coming back to the main point, and we are generating those data, the congestion window change. So if you see all this data, you see all these numbers are nothing but the let's say this is the second and this is the number of the congestion window change. So at this particular time the congestion window was this, so whenever actually we have the packet drop and stuff, congestion window will change, and these are the logs for that. So we generate this file. So using this NS3 script we will be generating this file, and after that we will be making the graphs using GNU plot. But now what is the main problem while doing that is, since we are including this tutorial app.h file from the NS3 itself, and as we are using Web-NS3, this file may or may not be here, we are not sure. And one thing that we can solve this problem with is this option which is called upload source file. We can upload those files and we can refer by using this, or else they have given the example over here. So this is the example of how we can use the nested subdirectory from within the NS3 script. So this is how we can use this. As of now this might look very complex to you, but this is not much complex. We are going to see this in upcoming videos. But now since the script is really small, what we can do is there is an alternative way. So let's say we are including this tutorial app.h file. Rather what we can do is we can make and define whole or this entire file in just one script over here. So in that way we are not required to include this class, this file, this custom file. These files are this is comes with the NS3 build, so this doesn't have any problem. This is the C++ file library, so that is also inbuilt available with the build, so that is also we are not something to worry about. But this file we can define in same file only. So this is the how you can do that. So first problem is solved. What I have did is I have created the the tutorial app file. So if you see, this is the file. This is the file that we are including inside 6.cc, and this is the combined file that I have created. So I have created the entire so if you see at this point we are starting the 6th script example, and until this all these lines were for the tutorials app. Now so this you can do easily if you know C++. So now beyond this point everything is pretty much simple. So what we are going to do is, so what my goal is, let's say we have this client. If you see over here, so this is the application, client application, and we can change the data rate as per we want, and the channel data rate, so the data rate of the channel that is used to connect both server and client, that is 5 Mbps. So what happens, let's say we keep this client data rate at 1 Mbps, and how the TCP algorithm behaves, that we want to check, and that we can easily check if we have the graphs, and so that we can make our conclusions. So what I have did is, so this same file I have uploaded over here, and what I have created is, I'll just show you. So I have created one parameter, command line parameter. So if you see, I have created one parameter which is called data, and the data is nothing but the uint32. So let's say by default it's 1, and we are getting this from command line arguments also. So once we, let's say, write 2 on the command line arguments by --, this option in such a way, ns3 and the target file that what we have, then --, then space, then --, data is equals to, let's say, 2. So what it will do, it will take the 2 data, it will convert it to string, and it will append mbps. So that way the whole 2 that we pass over here will become 2 mbps, and it will be supplied over here as a client data rate. And we want to observe that how the TCP cubic, as we have configured TCP cubic, how it behaves with that parameter. So that we are going over here. But now what I want to do is, I want to run I want to make 5 runs of this same script, and in such a way that for each run, this data command line argument data value, it should start at 1, it should end at 10, and every time it should take step increment step of 2. So for first run, first execution, the value of data parameter will be 1. For the first run, second execution of this file, the data parameter value will be 3. And this is how 5, 7 and 9, this is how it will go. So if you look it already, I have a script over here. So this is the script. So if we go under the results, once we execute this script over here, once we click on run simulation, it will start the simulation. It will take some, let's say, 5 minutes or so. So once the execution is completed, we will have this kind of files. So you see run 1, which means the first run, and all the data parameter command line argument data values that is changing, that is logged over here. So data 1, data 3, data 5, data 7, data 9, and this is the end of first run. Now second run, third run, fourth run, fifth run, and so on you can configure. Now if you click on this folder run 1 data 1, so this is the first execution of first run where the data parameter value is 1, and these are the readings that we have got while executing the ns3 script. And this is the pickup file. We won't be able to observe it over here, but you can download, and this is the terminal output. So what we can do is, we can take this seconds and this congestion window at x and y axis respectively, and then we can just click show graph. So this is very easy. We are not required to use GNU plot and any kind of overhead as of now. And once you click this show graph, you can see this beautiful graph over here, and you can make a conclusion out of it. Now you can take a screenshot or something, and then if you can also click on the run 1 data 3 and show graph. I would like to request over here to the ns3 team that what we can do is, let's say if we are generating, we have same file under each and every run, then we should see some options to take this action on each of the file. Let's say for each of this file, we take this x value and y value, y axis value, and if we click on show graph, we can see graph for each run. So for first run, if there should be an option, so for first run we should see all those files, all those graphs. We can directly compare all those graphs. So currently, if let's say I want to compare those graphs, I need to take a screenshot, and I need to compare first screenshot I'll put in half of the screen, second screenshot I'll put in the other half of the screen, and then I can make my conclusion. Rather than that, if they had an option to show all the graphs of first run over here by performing certain actions, so that would be very helpful, because in every run we will have the same set of files as we are running the same script. So that is one feature that I would like to request to the Web-NS3 team, so that we can have a very easy visualization or stuff like that. Then we can just go through all the files, and we can have our look that how the algorithm is behaving. So you see we have so many drops, the consistent time at the data rate of 5, and now if we go beyond 5 we should see more number of drops. You see, because the channel bandwidth is 5 Mbps and we will be reaching the maximum capacity of packets on the all the channel so many times. So that's why we will be hitting so many drops over here. So this is the way you generate so many graphs with just a few clicks, considering that you have an SS script already. So you see, these are the readings that we have taken, and this is very easy. So I hope you have got the idea about how we can use the Web-NS3 to this feature. Basically, if I can see, sorry, not results, if I can tell you. So in this video we have explored this number of runs. So this option, this is very useful option. I'll suggest you should explore this option with your scripts, and you should try experimenting with this stuff. It's a really an useful feature. So I hope you have got the idea about this one. So that's it for today's video. We'll meet in the next video. We'll plan so many good videos on Web-NS3. So subscribe to the channel if you are new to this channel, or if you are watching this for the first time. So yeah, that's it for this video. We'll meet in the next video. Till then, keep learning and keep exploring.